Hello students, these are the notes for Wednesday's class. Today we're going to be looking a little bit deeper at the lines and the transversals and see if we can't discover a few properties about the angles that we talked about for yesterday's class. So let's get started. Okay, our objective for Wednesday will be the student will learn the properties of basic sets of angles occurring around parallel lines and transversals. Again, this is for Wednesday, October the 16th. So please copy your objective and the date. As always, press pause anytime you need more time to copy something down, and then hit play when you're ready to move on. Okay, now when a transversal intersects two parallel lines, the angles that are formed have various properties. Now for yesterday's material, we were only concerned with the names of the angles that were formed around the intersections. Okay, so we looked at a diagram that was very similar to this. We had two lines running kind of horizontally, and then we had a third line that came along and intersected both of them. Okay, so this third line, the one that is kind of positioned up and down in this diagram, we called it a transversal because it hits two or more lines. Now, the two other lines that the transversal hit, we did not care really much about what those lines were doing. We just cared that the lines did get intersected, and that caused the four different categories of angles that we talked about for yesterday's notes. Now we're focusing on what is going to happen with these angles when those two lines are forced to be parallel. And you can notice in the diagram there that the lines are parallel because of the little red triangles inside of the body of the lines. That was one of the ways that they can tell us that we have parallel lines, little matching arrows or little matching triangles in the body of the lines. Okay, so the key is that everything we are looking at today, in order for any of it to be true, the lines must be parallel. Okay, we will go through the four different types of angles again, and we'll see what happens when these lines are parallel. So here we go. If two parallel lines are intersected by a transversal, then your corresponding angles will be congruent. Now, of course, remember from yesterday, corresponding simply means they exist at the same basic position, but at different intersections along the transversal. And remember that the word congruent simply means equal measurement. So we're going to use that same diagram from the first page. You do not need to copy it down over and over. You can simply refer back to it. But here is the diagram from the first page again. Okay, now where are corresponding angles inside of this picture? Let's start off with angle 1. Which angle at the other intersection would correspond to angle 1? Well, that would be angle 5, because they both exist basically up and to the left of their intersections along the transversal. And since the lines are parallel, the following things are going to happen. Angle 1 and angle 5 are going to be congruent to each other because they are corresponding angles and because the lines are parallel. But as we saw yesterday, that is not the only set of corresponding angles in the picture. We could say angle 2 and which other angle? Angle 6. Those are corresponding angles. And since the lines are parallel, that means 2 and 6 are congruent. How about angle 3? Is there an angle that corresponds to angle 3? Yes, there is. Angle 7. Since they are corresponding and the lines are parallel, then angle 3 and angle 7 are congruent. How about angle 4? Is there a line or an angle that corresponds to angle 4? Yes, there is. Angle 8. Since they are corresponding and the lines are parallel, then angle 4 and angle 8 are also congruent. Okay, now same basic rule, so you can probably abbreviate your notes just a little bit. Okay, but now we're talking about alternate interior angles. If two parallel lines are intersected by a transversal, that's the way all of these rules are going to start today, then your alternate interior angles are also going to be congruent. Same diagram as before, so don't copy it down unless you feel like you need to. Now let's look and see where our alternate interior angles are at. Alternate means they will be on opposite sides of the transversal from each other. Interior means they will be in between the two intersected lines. So angle 3 and angle 6 are alternate interior angles. And since the two lines are parallel, this rule tells us angle 3 and angle 6 will be congruent. Any other sets of alternate interior angles in the problem? How about angle 4 and angle 5? They are alternate interior, and since the lines are parallel, that makes them congruent. Any other sets of alternate interior angles in this diagram? No, those were the only two sets, and there's the rule for alternate interior angles. The next rule we talked about was for same side interior, or remember they're sometimes called consecutive interior angles. Our rule starts off the same way once more. If two parallel lines are intersected by a transversal, then your same side interior angles are going to be supplementary. Okay, remember that supplementary means they will sum to 180 degrees. Same diagram as before. Where do we have same side interior angles? Well, same side means they're going to be on the same side of the transversal with each other. And of course, interior means they are in between the two intersected lines. So angle 3 and angle 5 would be same side interior angles. And since the lines they are at the intersections they are at are around two parallel lines, then angle 3 and angle 5 are going to add to 180 degrees. They are supplementary. Any other sets of same side interior angles? Yes, there are. How about angle 4 and angle 6? Okay, since they are same side interior angles and the lines are parallel, then we have angle 4 and angle 6 being supplementary. Any other sets of consecutive interior angles? No, that was the only two sets in this diagram, and there's your rule for same side interior. Lastly, if two parallel lines are intersected by a transversal, then your alternate exterior angles are they are congruent. Same diagram as before. Okay, where do we have alternate exterior angles in the diagram? Angle 1 and which angle would be alternate exterior angles? Alternate means they're going to be on opposite sides of the transversal. Exterior means they will be on the outside of the two intersected lines. So angle 1 and angle 8 would be alternate exterior angles. And since these lines are parallel, that means our alternate exterior angles, angle 1 and angle 8, are going to be congruent. Any other sets of alternate exterior angles? How about angle 2 and angle 7? Okay, those are alternate exterior. The lines are parallel. That makes them congruent. Any other sets of alternate exterior angles? No, those were the only two sets in this diagram, and there are your alternate exterior angles. Now you'll notice that 3 of our 4 sets of types of angles here were all congruent to each other. There was only one set that was different, and it was supplementary. People often have a difficult time remembering which of the sets is going to be supplementary. I have a silly little way to help you remember. The one set that was supplementary was same side interior. Okay, supplementary, same side interior, supplementary, same side, supplementary, same side. So if you'll just remember that all the S's go together, then that should get you past that one little catch, and simply remember that the other 3 different types that we have, those are going to be congruent. Same side, supplementary, all the others are congruent. Okay, I've got an example here, and I don't particularly want you to copy it down. I just want you to follow along with me. We're about to start to see how some of this math is going to apply to some of the pictures, diagrams, and I want you to see how many different ways there are that this information, plus some of the definitions that we've covered in the past, can start to spread itself through our diagrams. Okay, so here we have an example. Okay, we have a couple of parallel lines. We have a transversal intersecting the parallel lines. And around this transversal, we have a couple of angles marked. The one in the lower left marked as 110 degrees. The one at the top intersection on the right side marked as x degrees. And the instructions are to find the value of x. Well, the challenge of geometry is going to be, as I've told you before, to write an equation that is going to allow us to say that, hey, this thing over here is equal to that thing over there, so we can solve it. Or maybe these things will add together to equal this other stuff over here, so we can solve it. We have to be able to establish that something is happening that is going to equal to something else that is happening. Okay, so let's see if we can't find a way. Well, look at these two angles in the picture. Are these any particular type of angles that we know about? These don't fit any of the four categories that we have talked about the last couple of days. So what we're going to have to do is figure out a way to manipulate this information so that we can find out what kind of angles we might be looking at. Okay. Since these lines are parallel, we have our new rules, and we can use those to spread the information throughout the diagram. For example, we could use the corresponding angles rule and then allow it, the linear pair definition, to take over from there. So we could move the 110 degrees from here. It could be moved up here to this this angle. Okay, which doesn't necessarily tell us what x is, but if that 110 degrees is sitting where the orange arrow is pointing at, then we would have a linear pair between 110 degrees and the x degrees. Linear pair, they add together to equal 180 degrees. We would be able to solve it. But that's not the only way it could have been done, or the only way it could be thought about. For example, we could use the alternate exterior angles rule. That would move the 110 degrees where the red arrow is pointing up top. Okay, and once again, you would have a linear pair between this new location of 110 degrees and the x degree angle. We would be able to add them together to equal 180 degrees. We could solve it from there. Okay. We could also apply the vertical angles rule from where 110 degrees was. Remember, vertical angles are across from each other at the intersection, right there where my pointer's moving across. Okay, and then you could apply the alternate interior angles rule, which would move the 110 down here again. Okay, and then you'd have linear pair once again with the x degree angle. We would be able to add them together to equal 180 degrees. I think you can see the recurring pattern in here. Okay, wherever we are able to legally move the 110 degrees to, okay, it's going to consistently put it in a position where it's going to want to add together with the x to equal 180 degrees. From the equation we're looking at there, all we would have to do then is subtract 70 from both sides of the problem, and that would tell us that x is going to be equal to 70, which would make the angle 70 degrees. Okay, we're going to have to practice on setting up these equations quite a bit. This is the thing that causes a lot of people grief in geometry, is trying to figure out how to set up an equation based upon a diagram so that we can do our Algebra 1 and solve the problem. We'll work a couple of examples in class on Wednesday. If you would please take a couple of moments and copy these examples down. Okay, copy this diagram. Leave yourself probably 6 or 7 lines on your paper. Press pause if you need more time. And then copy down this diagram as well. And leave yourself, again, 6 or 7 lines on your paper. We will work these out together in class before we get busy doing some practice work. And that is all. I will see you in class on Wednesday. Have a good night.